Section 6.1, evaluate nth roots and use rational exponents. What does this mean? All right, we know from working with exponents already that we can have a base and an exponent, and we know that this particular example of 2 to the third power means multiply 2 times itself 3 times. 2 times 2 times 2 equals 8. Well, we go backwards with this statement. Basically, we can go, basically move the 3 over to the 8 and say, 8 to the third power equals what number? In other words, what number times itself 3 times gives us 8? And we know from this example, of course, it's 2. So it's the same information, but it's kind of going backwards. Okay, so further point. We all know how we can square a number, and we also all know that we can have a square root of a number x, and we could perhaps square that, and when we square or square root, it cancels out and we just have x. Well, in terms of exponents, we can square something, and the opposite would be the square root, or we can think of it as a half for a power of 2, or a third for a cube, or a fourth for a fourth power. So we'll be using these exponents, fractions, going forward. Some more information for you. As we write these exponents, rational exponents, and fractions, we know a square root of a is now the same as a to the 1/2. If we have a to the third, it's the same as the cube root of a. So you just put the 3 inside the bracket there, or the fourth root. So these are the exact same thing. You'll see in both ways. Now, some rules that I don't want to get into now, they're here. And the best way to really observe these rules is to see some examples as we go through this section. And then we'll come back and point out the rules. These will become evident as we do the work, because the math won't lie. Numbers will give us the answer. But we'll see the pattern, and then we'll come back and discuss them here later. All right, let's try a few examples here. And the more you do of these, it gets pretty easy, and we'll do a lot of examples. All right. So here's kind of the basic setup. You have a base to a power, and it gives you that number. Well, let's put this information here and see if we can figure this out. So we know that n's 3, so it's up here. So we have b to the third, and a is negative 216. Well, we're trying to solve for this b, so if we take the third power out of this side, so b equals negative 216 to the 1/3 power, or b equals the cube root of negative 216. So what number times itself 3 times gives us negative 216? And this negative is kind of interesting. If you know about square roots, you can have a negative number. But you know how to multiply negative numbers. For every 2, it comes out positive. And when you have an odd one, it'll make the result negative. So what we have for an answer here is b equals negative 6. Okay, now multiply negative 6 times itself, times 3 power, you get back that 216. Let's try some more examples. This gets easier as we do more. Here's the next one. N to the fourth, there's a fourth power, and the b, the base, we don't know the base yet. A is 81. So it's the fourth root, so we'll take the fourth root of both sides. B equals, again, 81 to the 1/4. Or if you like, doesn't matter, these can be the same. I'll say or here, equals the fourth root of 81. Again, you can decide which way you like, but you got to be able to go back and forth between these two forms. So what number times itself 4 times gives me 81? Well, 3 times 3 is 9, 3 times 9 is 27, 27 times 3 is 81, so b equals 3. And you can check your work. B, or 3 to the 4th power will equal 81, so you can always check your work as well. Some more examples in here if you turn into the guided practice, next page. Again, you get used to setting up the form. You have a base to a power, and it equals the a. So the base here on number 1, we don't know the base yet, it's the 4th power equals 625. And again, calculator, I'll show you how to use a calculator in a minute for these. But 5 times 5 is 25, times 5 is 125, times 5 is 625. But again, even before we get to the answer, you might want to move this, take the fourth root of both sides, so you have b to the 625 to the fourth, or again, one more time, the fourth root of 625, and b equals 5. All right, let's try the next one. Bases unknown, exponent negative 64. Again, you're going to see some, when you have an odd number exponent, you can have a negative here. So what number times itself 3 times is 64, or even negative 64, so this would be b equals cube root of negative 64. What number times itself 3 times is 64? That should be negative 4. So b equals negative 4. Again, check it out. Negative 4 to the third power, 16, positive 16. And positive 16 times negative 4 will get you the negative 64. All right, here's another one. B is unknown. Power 6 is 64. Or b equals the sixth root of 64. Something you get used to. This is going to be 2. B equals 2. 2 to the 6th power equals 64. A lot of these are new problems for you to solve. They get easier the more we do of these. So just hang in there for a little while. Last one in the set here. Again, b to the 5th power equals 243. b equals 243 to the 5th. Again, I'm showing you different ways here each time. So just get used to it. It's both the same thing. You decide what style you like best. Now, what number times itself 5 times is 243, and I think that's going to be b equals 3. 3 to the 5th. Rational exponents. A rational exponent does not have to be in the form of 1 over a number. 1 to the third, 1 to the fourth, 1 half. But other rational numbers, such as 3 halves or negative 1 half, can also be used as exponents. And that seems very complicated. But this is not that difficult to understand. 2 properties of the rational exponents are shown below. So here's an example. X to the 3/2 power. Well, not x, but 16. 16, 3/2. Let's break it into pieces here. Let's worry about the fraction, the 1/2 fraction. We know that the 1/2 fraction, n to the 1/2 equals the square root of n. All right, so we know we can take the square root of 16. What is the square root of 16? It's 4. So we take the square root of 16 and get a 4. The 3 is still here. What's 4 to the 3rd power? 4 times 4 times 4? 64. So you do the root power, root first, and then do whatever other, the other part of the exponent afterwards. If you do this first, you get some very big numbers, and it's harder to work. Try to always work at the fraction part first. Let's try letter B here. It says 32 to the negative 3/5 power. So we want the 5th root of 32. Again, this is to the 5th root of 32. Hopefully you know that that's a 2. Okay, so that 5th root of 32 gets me negative 3, or 2 to the negative 3 power. Well, we know 2 to the 3rd power is 8, but it's a negative exponent. So, 2 to the 3 is 8. The negative thing is down to the denominator, so it's going to be 1 over 8. Pretty tricky stuff. Let's try a few others for you on those down below here under guided practice. All right, so 4 to the 5 halves. This half means, 4, or just square root of 4. That's 2. So we use that up on the 4. We have 2 now to the 5th. 2 times 2 times 2 times 2 times 2, 32. Okay, here we go again. Another negative. We do the fraction first. Square root of 9 is 3. So it's 3, because the half and the 9 are gone. We have negative 1 left. That drives it down to the denominator, 1 over 3. Number 7, we have 81 to the 3/4 power, or look at the fraction first, 81, or the 4th root of 81. That should be a 3. That equals 3. So now, we use up the fourth and 81. We have 3 to the 3 power, 27. And this was pretty simple. The 8th root of 1 is just 1. Doesn't get any smaller. And then 1 to the 7th power, 1 times 1, up to 7 times, just starts with 1. All right, now let's try some calculator problems. Example 3. We'll use a calculator for this. Chromebooks may work. I don't know what utility you go to. TI-30s can do the trick. For the TI-30, you have the caret key here, which forces the next keystrokes after that to go up into the exponent. And you just type in parentheses whatever fraction you have. So if I want to find out what the 5th root of 9 is, now it's going to be a small number. So I will take 9, just want to make sure I clear this first. So 9, hit the caret button, and now in parentheses, I got the parentheses, 1 divided by 5, close the parentheses, just to make sure that you complete this operations in here first, and enter, and there's 1.55. That sounds about right. Okay. Next one, 12 to the 3/8. So again, once you do a couple of these, it's pretty easy. So 12, caret, parentheses, 3 divided by 8, close, and I have 2.5, 2.539. One more, don't be confused by this. This looks a little tricky. This is the same as saying 7 to the 3/4 power. Remember, the root here can be written as a fraction of the exponent. So I'll take the 4th root of 7 and times 3. But I'll do it all as one as 7 caret, parentheses, 3 divided by 4, close. What's that, 4.303? That's pretty easy to do. Try going, 3 all the way through 33. There, 33. And there'll be some also problems from the worksheet. I'll make some more examples for you as you're doing these problems in the next video.